Okay, so today we are going to solve the problem minimizing coins. Okay, in this question, consider a money system consisting of n coins. Each coin has positive integer value. Your task is to produce a sum of money x using the available coins in such a way that the number of coins is minimal. So what we have to do here is we have to find what are the minimum coins we would require to get a desired sum. So, for example, if the sum is 11, we would require three coins, that is 5, 5, and 1. And we can also see that there is no other possible combination which will require less than three coins, because if we have to do it with two coins, then 5 and 7, it would be greater than 12. Okay, so this is our question. So, how can we solve this? Okay, the question is we are given a n, we are given a n, or you can say x, and we have to find minimum coin required to get n. So remember what we talked yesterday. If anything which can be solved using previous states. So suppose the coin given are 1, 3, and 7, and we would require something say 15. So how we can get this sum 15? Suppose we take 1, then if we know what would be the value for 14, then we can get the value 15 by simply value plus 1. Whatever value is for 14 plus 1. Similarly, if we take 3, okay, so if we take 3, then we would get 12. So if we know the value of 12, we can get the value of 15, value plus 1. Okay, similarly for 7, if we know the value for 9, no, 8, we can get the value for 15. So similarly, if we want to find for 14, we can get by taking 1, 3, 7, and we can take the minimum of everything. So minimum from these, these, and these. We can take minimum of all three. Okay, so this would be how would be your let's start. So if we want for a certain value, let us just solve. If we want for value, okay, so how can we get for this value? We can get an answer which would be, let's say, an impossible value or infinite value, 1 in n. We know that there would be no 1 in n. So now for every coin, x in coins. So for each coin that is available to us, we can say that answer is minimum of value minus coin. Okay, minimum of value minus x, whatever would be the x and answer. And we can simply return the answer. And if the value minus x gets negative, then if value is less than 0, return minus 1. If value gets 0, we can return 1. So these two would be our base cases. If value less than 0, return -1. If value is equal to 0, return 1. Okay. We can do it iteratively. Uh, we can start from 1 to whatever value we have to find. Let's say n. And the, for every value from here, we can define dp of 0 equal to 1, which would be there is one way to get 0, which is don't take any coins. So from 1 to n, we can go from every value in coins, and we can simply do dp of I equal to minimum of dp of I comma dp of I minus x plus 1. This way, we are only going to require the smaller value. Means whenever we would, in writing a iterative dp, we will start from what case would be required first. So we already defined 0. Then when counting 1, we will only require the smaller values than 1. So they would be already calculated for every time. Every time that would be calculated. So this way we can find the answer. Okay. Main thing, visualize. So how this would be working from 0. Okay, when finding 1, suppose the coins are 1, 2, and 3. We will look for 1, we will look for when 2, we will look for 2, 1, and for 3, we will look for 2, 1, 0, this way. Okay, so let's write us code now. Uh, We can also discuss the time complexity. Like we would require, we are what we are iterating, what we are iterating here from 1 to n, and here the coins size. Okay, so as we can see, the coin size can go from 1 to 100, and the number which we have to find can go to 1 e power 6. So that would be 10 to the power 6 into 100. That is x into n. And that is less than 1/8. So I think this should be work. This should work. Let us nxn. Okay. Int n x 3. We will define it with int maximum value, because if we can't find any particular if we can't make any sum, like if there are only one coin, so we would never get odd sum, right? So if suppose there is only just one coin, 2, so no matter how hard we try, we will never get 3, 5. So for that case, we would initialize our DP with max value. So whenever if we get a max value, then this can't be made. Now, let us define our DP. DP of I will give us minimum coins required to get some I. DP of 0, 1, this case, for I into I equal to I will be equal to for every value in point. Oh, yeah, we forgot to take the points. Now, GPO 5 equal to GPO 5, GPO 5. That is if I minus x is positive. We can also do a slight if it is possible to get that value. Then only we will move on to update it. Now, if dp of x equal to not equal to max, then only see out dp of x. Otherwise, let us check this input. Where is sorry, sorry for the zero. There is zero. We can take 0 points. Okay, so this will work. As you can see, this is accepted. Okay, thank you guys.